In our cluster of excellence, UniSysCat, we are revolutionizing catalysis.
Why and how? And what is catalysis anyway?
I will show you what catalysis is using a chemical reaction. Here you can see in the balloon how hydrogen and oxygen form water.
But there's nothing happening there.
That's right. It's all quiet at the moment. And then, like Prometheus, I'll come to you and bang, the oxy-hydrogen gas reaction. Yes, hydrogen contains a lot of energy.
And I'm supposed to use this as fuel in my car?
Sure, you can blast off like a rocket or use a catalyst. Hydrogen is an interesting fuel. You just have to know how to use it. A bit of chemistry is all you need.
And what does the catalyst do?
Without the flame, nothing happens. Hydrogen and oxygen remain hydrogen and oxygen. We need energy to split the bonds in hydrogen and oxygen before they can form water. Or we can use a catalyst. The catalyst replaces the flame on the one hand, but also helps to control the combustion by regulating and accelerating the interaction of the hydrogen and oxygen molecules in the reaction. The Chinese word for catalyst, for example, translates as matchmaker. And afterwards, your car doesn't emit carbon dioxide, but just steam.
But catalysis is chemistry, and chemistry is dirty.
Sure, and electricity just grows on trees. Seriously now. Try to imagine a world without chemistry and catalysis. If you followed that line of reasoning, there would be no antibiotics, washing detergents, cars, dyes, glues, plastics such as polymers, certain textiles, mobile phones, computers, flat screens, fertilizers, and so on and so forth. Eventually, you'd end up in an overcrowded version of the Middle Ages.
Yes, but all this requires so much energy. And we're in the middle of a climate crisis.
The energy of the sun that shines on the earth in a single hour is enough to cover the needs of humanity for a whole year. So we're not lacking the sources of energy. We just need to learn how to harness them.
But the energy problem's for engineers to solve, not chemists.
It does require engineers, but also physicists, chemists, etc. Because catalysis doesn't just help to save energy, it also facilitates energy conversion and energy storage. And to achieve this, we also need biologists, because we want to learn from nature.
Learn from nature? What are you going to do? Watch trees grow?
Exactly. Nature shows us on a large scale, e.g. in the form of trees, how sunlight and the greenhouse gas carbon dioxide can produce wood, a form of storing the sun's energy that is both safe and useful. In order to understand how this works, we need to understand nature on a very small scale, i.e. on the molecular level. Because only then will the tree show us how it converts light energy and water into oxygen, and ultimately how it also traps carbon dioxide. It's about capturing the energy of the light and using it.
I don't see the connection between light and chemistry. Light has to do with physics.
Then look here. I mix two chemicals and what happens? Let there be light. And of course, catalysis is again behind this, because in this case, iron ions help to release light from a chemical compound. Like trees or phytoplankton in the oceans, we want to invert this and use light to produce new compounds, like producing fuel from light with carbon dioxide and water.
Sounds good. But how do you hope to do that?
I already said, we're going to revolutionize catalysis. We will need to bring together chemistry, biology, and physics to do what we have been doing inefficiently up to now in huge chemical plants, like bringing the cells of our body together to form one efficient network and then activating it with light. To ensure that this works, we're developing special new catalytic and sustainable processes that will allow us to manufacture products economically and efficiently. These processes will also have very little negative impact on humankind and the environment. For example, they use renewable resources and avoid waste. This is green chemistry, and we want to promote it. It all started with an idea a number of years ago, and now we've nearly reached Greenopolis.
Do you see that big chemical plant there? Wouldn't it be great to optimize it using the example of a living cell?
Yes, nature grows and thrives without producing waste and exhaust fumes.
Friends, I've got it. We'll combine the two worlds of chemical and biological catalysis.
A lengthy discussion ensues.
We will use sophisticated methods to gain a detailed understanding of the processes that take place within cells.
Exactly. We will create this chemically and combine both.
The combined bio-inspired chemical catalysts will make our plant clean and efficient.
And with our new catalytic system, water can be used to make fuel, for example.
That's the Greenopolis way, combining powers to make chemistry sustainable.